So hi there, we're at GOTO Aarhus conference 2014, and we have James Lewis with us from ThoughtWorks. James has been here many times talking on all kinds of interesting infrastructure, agile things, and this time around he's giving a tutorial on microservices.
Yeah.
And I have to admit I'm somewhat ignorant on this microservices thing. I've heard, of course, this is a new cool thing, the new buzzword that I guess I'm supposed to know about.
Yeah, it's even got like a Greek letter people use. Yeah, it must be cool, right?
Oh yeah. So what is it?
Yeah, well, I mean, this is the thing. For me, what's interesting is that it's the new cool thing, apparently. Except when we talk about it, myself and Sam Newman, a colleague of mine, that we've done a lot of work together in this space. Generally, actually, we talk about the fact that it's about 40 years old.
Which is usually a good thing, right?
Yeah,
okay.
And what we talk about is a huge set of practices that have come together, a bit like extreme programming, I think. Just a load of sensible things that people have built up over time as practitioners in the software world. Building software, I should point out, I still write code 60-70% of the time. That's and it's a load of practices that have sort of come together over the last, well, certainly the last decade. That when you put them together, they kind of make more sense. So they're kind of complementary to one another.
So, over the last decade, we've had all these people talking about SOA, and probably a lot of people have an opinion about SOA.
Sure.
So how does it? How do you position it relative to that? Maybe that's something that people can relate to.
No, absolutely. So I think for me, the main problem has been with SOA is that it's been sort of stolen, if you like, by big IT. You know, it's sort of been it's turned a set of really good ideas about how to structure software systems has turned into this kind of, thou shalt buy this big piece of technology, thou shalt do a 5-year program to implement a whole bunch of stuff. And this kind of comes back to what I was saying about building on better practices. So, for example, Jim Weber was talking a few years ago now about Guerrilla SOA, right, which is a sensible approach to building out service-oriented architectures, right? And it's building on things like Guerrilla SOA. It's building on the move towards using web integration everywhere rather than just out there on the websites. It's building on the new newer practices around programmable infrastructure and all these sorts of things, and bringing it together to become sort of a slightly more cohesive and greater than the whole.
So you present this as like as a cohesive, like a pattern language more than just some random patterns. This is really, there's a whole set of things that go together.
I think it is, and I think they're mutually complementary. Is the technical term, I think.
So what are the main patterns in this language of microservices? Yeah.
So I would say that there's a bunch of things. The first thing is the idea of things like local transactions. So moving away from the idea of having some kind of orchestration of services and having something that says do this, do this, do this, towards having individual components that encapsulate their own logic and are able to react to follow their own state machine, as it were, and react to external stimuli. So this is the kind of idea of choreography over orchestration. That would be one thing. I think there's something around data sort of decentralization. So moving away from the idea of having a big database with a big box above it, it's moving towards having services that own their own data, services that own their own data. I think there's certainly something around continuous delivery. I mean, that's probably the big thing that has made a lot of the patterns possible, if there are patterns in the microservices world, because there aren't at the moment, right? It's
like logical ways to think of structure the solution.
Yeah, right? Exactly. So things like continuous delivery. How do we structure applications to best take advantage of to best take advantage of the idea that we can maximize flow of requirements from concept into, well, soup to nuts is a comedy phrase I heard last year. From concept to cash, because these days we want to structure applications such that we can have such that we can get individual changes through into production automatically, if possible, as quickly as possible. Adrian Cockcroft talks about this. He says, it's the reason Netflix do this is because it enables them to go as fast as possible to make changes and
you make the various parts more independent, basically, and it lets you move them independently also.
Exactly. So there's I guess I talk quite a lot about, and this is not something that I came up with, but the idea of architectural flex, or degrees of freedom in an architecture. If you have one big system, then you have very few degrees of freedom, effectively, in terms of scaling for availability or throughput, load and these kinds of things, or deployment or change. Whereas if you separate some of these concepts out, then actually what you get is many more degrees of freedom. So this thing over here, this needs to be deployed on a slightly bigger piece of kit than this thing over here. We don't have to scale to the highest common denominator or lowest common denominator anymore. As an example, my current project, we're finding exactly that. It's given us options that we can exercise at a later date. And that's actually very useful, I think, when you're designing software systems.
So I can see a couple of hard problems in this.
Sure.
Right? There's the actual deployment of like a complex setup. It's of course it's much simpler to just deploy one big J2E app on one app server, and there you go.
Yep.
On one big piece of hardware. Right. So it's a big complication to do that.
It is, and
so what do you do about that? There's that thing, and then the other thing is splitting up the data in many different individual databases. I can see people at least being afraid of how to gain consistency.
Yeah, sure.
And because they like to have this dashboard of everything being in a consistent.
Yeah, you
setup,
want kind of foreign.
So those
keys,
two
right?
things,
Yeah.
So those two things, how do you tackle them?
So I'm going to push the infrastructure thing onto the stack for a moment. But on the other question, which is around you're talking about data and consistency and things. I think that's actually a wider. It's a sort of aspect of a wider question in some ways, which is, do you start off building separate applications, or do you start off with a monolith and split later, right?
Okay.
And this is, I think, at the kind of core of it, because we've seen a lot of, especially as it's becoming more widely known, a lot of teams are sort of, okay, we'll just split everything up into all these different.
Yeah, we've had projects where we would split up too much early on, and then actually later we realized we need the relationships in the data.
But it's also, if you're working in the code every day, it's also really hard to refactor. It's really hard to explore. The great thing about unit tests, for example, for me, is the way they allow me to explore the design of my code. It's really hard to do when you've got a bit of code over here and a bit of code over here, especially when you're exploring the domain.
So do you want to start out with one big or with many small?
Well, this is the core question.
Okay.
Because I don't know if I have the answer.
Okay.
Right. Because if you look at Amazon, for want of much information coming out of Amazon, but where they came from was the kind of big database, big applications splitting out into a service-oriented architecture. If you look at Netflix, very similar. They had a big monolith with a big database, and they separated it out later. You look at I think people like Groupon and SoundCloud, and there's a number of these organisations. What they're finding is once they've explored and once they've hit the limits of what they can do with a particular system, for some reason they always seem to be Ruby on Rails. I don't know why that is. When they've hit the limit of what they can do along these flex lines, these degrees of freedom, they're splitting out. I don't know if that's the right way to go.
Well, then you also at that point you know your domain much better.
Yeah.
because often
exactly.
If you're building the first big app, that's also where you're learning a lot.
Yeah. Yeah, exactly. So you're exploring, and you're able to do that if you've got all your code in one place, then you're able to do that I guess probably more easily than you are if you've got a bunch of stuff separating out into different applications. Now, on the other side, I would argue, talk about service-oriented architecture, I could argue that actually what we should be doing is just sensible stuff that we've learned how to do over 40 years, right? So, and is it sensible if you've got, say, my current project, for example, my current client, we've got a number of integration points that we're talking to. Now, we took the decision to hide those behind facades. Just so happens they're running in separate processes, they're separate applications, but it means we can control their interface, we can control their rate of change, we can put flex points in around scaling, and we can put a cache in front or not, or all these kinds of things. Now, is that microservices, or is that just sensible software architecture? You know, who knows? So, I think the coming back to your original question, which was around data and how do we know how to separate different parts, you know, which data goes with which part, with which application, then you know I think it's pretty nuanced, right? So either it's going to be pretty clear that these things are separate, or maybe you need to explore the domain if it's not clear first, and then think about separating them later. But of course, there's a cost. Either way, there's a cost. You know, if you separate things out and you find you have to put things back together because you're not able to refactor effectively across, or because concepts are, you know, in this thing and this thing should be together, then you have to pay the cost of the rework to put them together. Similarly, if you don't and you want to split them up later, there's another cost, because you know, I think we learned with Corba and you know, the kind of what's Martin Fowler's law of remoting, you know, or distributed objects. You know, don't, I think it's along those lines. You know, there is a cost to talking to things across the network.
So
you know, change your.
So this must also, I mean, what's your take on how this is related to this other big new thing of reactive applications? Have you looked into that? Do you have an opinion on it? Because it seems like they're very focused on having message oriented. The foundation for that is making asynchronous messages, and then more or less, I mean, many of the same things. You're more in the large scale kind of the problems in that space, but it seems like they should be coming together.
I suspect that there are patterns that fit very well from that world and the Microsoft. Yeah, as you say, they're kind of maybe more
in common.
Yeah, I think there are, but one thing. So you know, I work at ThoughtWorks, and one of the things we do is we publish the technology radar, and that's not a sales thing. That's just we do, and I'm on the panel that puts that together. And one of the things that came out the last radar session we had was event sourcing. Again, right now, event sourcing's been around for a very, very long time. Chatting with Martin Fowler about it, you know, the CCC, you know, the original original XP project was in part event sourced, and that's a fairly long time ago now, you know. But it's back on the radar, and the reason I think is because of things like the kind of reactive world is sort of picking this sort of stuff up. If you start to have independent applications which own their own data, then they have to communicate somehow. And often synchronous is not the right way to do that. Things like raising events, popping them on a bus, or using things, you know, lightweight things like Atom or whatever, which I know Greg Young has chosen for his event tool. So you know, I think that is definitely something that's. I don't know where it's like a cart and horse thing. I don't know whether that's the popularity.
The hen and the egg.
Yeah, exactly. Yeah.
They go together.
Yeah.
Okay.
Yeah, that's the one. Yeah. That's a better one.
So yeah, so the infrastructure thing. What do you do in that?
So
To just wrap up.
Yeah, to wrap up, absolutely. You're looking at a watch you don't have? I know you do.
No, I do. Yeah.
He does. That's cool. I thought you were just kind of miming. I've been here too long with James.
No.
So on the infrastructure side of things, I think actually that's the one thing that has happened now in the last few years that has really brought this stuff together. I think that's the kind of missing piece of the puzzle. You know, if you look at, say, again going back to the XP practices. There's a great diagram which is kind of like this interconnected web of practices, right? And each of them support others. And it's a bit like that, but with pair programming missing, without the infrastructure advances that have been happening, you know, programmable infrastructure. So, you know, all the patterns, things like Phoenix servers, things like you know, tooling like Chef Puppet or now Ansible, you know, very quickly being able to press your own golden images, and then, you know, all these kind of advances, especially with virtualization, and you know, that's been around for a long time, but that becoming widely available and almost the de facto option now for people starting new projects makes this manageable, because what you're doing is taking effectively the accidental complexity from your from a big monolith and pushing that out into the communication between systems. And if you haven't got a mechanism for managing that effectively, then that's kind of
Then it's
Yeah.
even more complex.
yeah, I think so. And you look at
Yeah.
what Adrian Cockrop's talking about, the work he did at Netflix, and now I don't know what they're up to now, like 650 plus services. There's a reason they've got like 40 plus open source projects.
So that's is that the takeaway? If you need to do one step towards microservices, you should go learn Chef or Puppet or something like that and start using that. Or
Yeah,
where do you start?
So this relates to the question of how small they are as well,
Yeah.
right? So what I talk about is not how small, it's about how many, and how many is dependent on how operationally mature you are. If you're in a CMMI level 5, fully certified shop where you have to throw something over the wall and 2 weeks later you might, if you're lucky, get something into production, or you have to make change requests which take 4 weeks every time you need to do something. Probably it's going to be more difficult for you to deploy this kind of this kind of architecture composed of lots of separate applications. However, if you're in the position where you can take advantage or move towards using one of the cloud providers, using Chef, Ansible or Puppet, or using some of the awesome open source monitoring tools and projects that are starting up, things like Drop Wizard and the stuff that's coming out of Netflix, the Historixes and the Chaos Monkeys. Well, if you're in a position to take advantage of that, it limits, I guess, your exposure to some of the complexity. So, and it allows you to take advantage of it. I think that's not really a soundbite, is it?
But I think it was good. Yeah. So I think we should stop here. Thank you very much.
You're welcome.